Before we go to the last part here, you have a list of polyatomic ions, and these polyatomic ions, basically they exist on the planet together. I mean, they don't come apart, they hang out with each other, they don't separate, they just exist like this. And so oftentimes we just treat them as if they are their own element. Almost all of them, with one exception down here, are anions. Okay, almost all of them are negative. We do have one cation, and that is the ammonium ion, which is NH4, has a positive 1 charge. But for the most part, these polyatomic ions are anions, and they're negative. And so they're going to bond with all the metals to form these tertiary chemical formulas, ionic chemical formulas, I should say. So you have a list of them on the back of your periodic table, and they also have their own individual names. This is nice. You don't have to memorize the name of the element or, remember what that's called, because you'll always have a sheet that'll tell you that if NO3 is bonded together, that it is nitrate, and if NO2 is bonded together, that it is nitrite. CN, carbon and nitrogen, with a negative 1 charge, is cyanide. So they have their own names, and that's nice. But first, before we learn how to say their names, we're going to learn how to write their formulas.
Mama, can you ask him to read stuff on his board?
Okay, all right, hold on. So these tertiary ionic compounds usually have to do, or I'm sorry, they are, they have these polyatomic ions. So this is my cation here, and this is my polyatomic ion. If I look this one up on my sheet, it says that its name, OH, which has a -1 charge, is hydroxide, and it's bonded with this metal, sodium. So polyatomic ions, they just exist together, out there in the planet, and they don't come apart. And that's why we always have to treat them as if they're basically like their own element. And your job is really just to kind of recognize them so that you can write their formula or be able to say their names. So let's just do an example. Let's do a formula between lithium. All right, lithium is in column 1 on the periodic table. It's a cation, it's a metal, it's got a positive 1 charge. And then phosphate, if I look on my sheet here, phosphate is PO4, and it's got a -3 charge. Okay, so phosphate is my anion, and lithium is my cation. So, just like in the past, I am going to crisscross the charges, swap and drop there, making this Li. I get a little 3, and then PO4, and we don't put the 1 there. We don't put the 1. If I put a 1 here, then that means there's like 41 oxygens. So I don't do that. It's a 1. So like in chemistry, it's not written. And there we have Li3PO4, lithium phosphate. Let's do another one between zinc. All right. Zinc, remember, always has a positive 2 charge, and acetate. Acetate is C2H3O2 with a -1 charge. Right, that's the -1 charge. So I'm going to swap and drop, crisscross, put that 1 down there, and put that 2 there. And so I have zinc. The 1 is, understood. C2H3O2. And how I put that 2 there is I use parentheses and the 2. So now you know where the parentheses come from and why there's a little number on the outside. Because this was the charge that was on zinc. Okay? Let's do another one. Let's do ammonium, which is our only positive polyatomic ion, and cyanide. So this is a bond between 2 polyatomic ions. So I have ammonium and cyanide. All right. They both have a 1 charge, positive 1 charge for the ammonium ion and -1 charge. So I'm just going to swap and drop those. And since they're both 1, I don't need any parentheses or anything like that. It's just understood that they would be 1. And so I have NH4CN. And so I know this has been your most overwhelming, probably, video lesson so far, but I have a little saying that goes along with my ionic formula writing. Famous saying goes, don't practice until you get it right, but practice until you can't get it wrong. Hoskins. I'll be coming around checking your work, 'cause I've got my eye on you.